previous video we have learned how to solve linear equation through cross-multiplication method. If you haven't seen that video, link in the description and in the I button. In this video, we will discuss the solution of such pairs of equations which are not linear but can be reduced to linear form by making some suitable substitutions. We now explain this process through some examples. 2 by x plus 3 by y equals 13. And 5 by x minus 4 by y equals minus 2. Let us write the given pair of equations as 2 into 1 by x plus 3 into 1 by y equals 13. This is equation 1. 5 into 1 by x minus 4 into 1 by y equals minus 2. This is equation 2. These equations are not in the form ax plus by plus c equals 0. However, if we substitute 1 by x equals p and 1 by y equals q in equation 1 and equation 2, we get 2p plus 3q equals 13. This is equation 3. 5p minus 4q equals minus 2. This is equation 4. So, we have expressed the equations as a pair of linear equations. Now, you can use any method to solve these equations, and get p equals 2, q equals 3. You know that p equals 1 by x and q equals 1 by y. Substitute the values of p and q to get 1 by x equals 2. That is x equals 1 by 2. And 1 by y equals 3. That is y equals 1 by 3. Let's see one more example. Solve the following pair of equations by reducing them to a pair of linear equations. Let us put 1 by x minus 1 equals p and 1 by y minus 2 equals q, then the given equations. 5 into 1 by x minus 1 plus 1 by y minus 2 equals 2. This will be our first equation. 6 into 1 by x minus 1 minus 3 into 1 by y minus 2 equals 2. This will be our second equation. Can be written as 5p plus q equals 2. This is our third equation. 6p minus 3q equals 1. This is our fourth equation. Equation 3 and equation 4 form a pair of linear equations in the general form. Now, you can use any method to solve these equations. We get p equals 1 by 3. And q equals 1 by 3. Now substituting 1 by x minus 1 for p, we have 1 by x minus 1 equals 1 by 3. That is x minus 1 equals 3. That is x equals 3 plus 1. Which is equal to 4. Similarly, substituting 1 by y minus 2 for q, we get 1 by y minus 2 equals 1 by 3. That is 3 equals y minus 2. That is y equals 3 plus 2. Which is equal to 5. Hence, x equals 4, y equals 5 is the required solution of the given pair of equations. Let's see one last example. A boat goes 30 kilometers upstream and 44 kilometers downstream in 10 hours. In 13 hours, it can go 40 kilometers upstream and 55 kilometers downstream. Determine the speed of the stream and that of the boat in still water. Let the speed of the boat in still water be x km per hour and speed of the stream be y km per hour. Then the speed of the boat downstream equals x plus y km per hour, and the speed of the boat upstream equals x minus y km per hour. Also, time equals distance upon speed. In the first case, when the boat goes 30 km upstream, let the time taken, in hour, be t1. Then, t1 equals 30 by x minus y. Let t2 be the time, in hours, taken by the boat to go 44 km downstream. Then, t2 equals 44 by x plus y. The total time taken, t1 plus t2, is 10 hours. Therefore, we get the equation 30 by x minus y plus 44 by x plus y equals 10. This will be our first equation. In the second case, in 13 hours it can go 40 kilometers upstream and 55 kilometers downstream. We get the equation 40 by x minus y plus 55 by x plus y equals 13. This will be our second equation. Let's put 1 by x minus y equals u and 1 by x plus y equals v. On substituting these values in equations 1 and 2, we get the pair of linear equations. After putting the values, we get 30u plus 44v equals 10. That is, 30u plus 44v minus 10 equals 0. This is our fourth equation. Replacing values in equation 2, we get 40u plus 55v equals 13. That is, 40u plus 55v minus 13 equals 0. This is our fifth equation. Using cross-multiplication method, we get. That is, u by minus 22 equals v by minus 10 equals 1 by minus 110. That is u equals 1 by 5. And v equals 1 by 11. Now put these values of u and v in equations 3, we get 1 by x minus y equals 1 by 5. And 1 by x plus y equals 1 by 11. That is x minus y equals 5. And x plus y equals 11. This will be our sixth equation. Adding these equations, we get 2x equals 16. That is x equals 8. Subtracting the equations in 6, we get 2y equals 6. That is y equals 3. Hence, the speed of the boat in still water is 8 km per hour and the speed of the stream is 3 km per hour. Let's summarize the chapter pair of linear equations in two variables. In this chapter, you have studied the following points. Two linear equations in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equations is a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0, where a1, a2, b1, b2, c1, c2 are real numbers, such that a1 to the power 2 plus b1 to the power 2 is not equal to 0. And a2 to the power 2 plus b2 to the power 2 is not equal to 0. A pair of linear equations in two variables can be represented, and solved, by the graphical method, and algebraic method. Graphical method. The graph of a pair of linear equations in two variables is represented by two lines. If the lines intersect at a point, then that point gives the unique solution of the two equations. In this case, the pair of equations is consistent. If the lines coincide, then there are infinitely many solutions, each point on the line being a solution. In this case, the pair of equations is dependent, consistent. If the lines are parallel, then the pair of equations has no solution. In this case, the pair of equations is inconsistent. Algebraic methods. We have discussed the following methods for finding the solutions of a pair of linear equations. Substitution method. Elimination method. Cross-multiplication method. If a pair of linear equations is given by a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0, then the following situations can arise. a1 by a2 is not equal to b1 by b2. In this case, the pair of linear equations is consistent. a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. In this case, the pair of linear equations is inconsistent. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. In this case, the pair of linear equations is dependent and consistent. There are several situations which can be mathematically represented by two equations that are not linear. In this video we have learnt about equations reducible to a pair of linear equations in two variables. In the next video we will learn about fourth chapter, which is quadratic equation. Till then, take care and don't forget to like, share and subscribe our channel.